and then we start on YouTube as well. Very cool. Okay, then we'll give it 1 more minute, ladies and gentlemen, and then we can kick things off. Super excited, Kelsey. Thanks for doing this.
Yeah, of course.
If you see me looking left and right the whole time, this is because I'm checking the chat. And
Yeah.
I feel like the operator in the Matrix where you have like 100
Yes,
screens. So
I appreciate it. I have just my one screen in front of me, so.
that is cool. And feel free to ask your questions in the chat function. So whether you're joining from LinkedIn or YouTube, just use the chat functionality and then we can make sure to answer your questions at the end. Okay, so it's 11 a.m. Central European Time, ladies and gentlemen. You know who I am, Yusuf Murat. I'm the host of the Deep Dive series, part number 2. And today I have the honor to sit together with Kelsey Crossman from simq to talk through simqvit. But what is simqvit in the first place? Kelsey, can you tell us? And what are we going to see today?
Yes, of course. Thank you for introducing me. My name's Kelsey. Like Yosef said, I'm the business developer at simq, and today we're going to be discussing the simqvit, which stands for Virtual Implant Testing. And what you're seeing here is the results of our program. But what I want to do is I want to start off just kind of explaining VIT in a general sense in simq and how we provide simulation in the medical device industry. Okay, so what is simqvit? The virtual implant testing software that we offer helps optimize the design of custom implants when they're designed by biomechanical engineers and with surgeons. So we can use the finite element method to test load cases on these patient-specific designs and then see how the implant, the deformation occurs. And then you can go ahead and see, okay, should we take the stress off a little bit here, etc. So the next question is where can you apply these this software and what kind of anatomical regions? So right now our workflow library includes a lot of craniomaxillofacial operations that's very personalized patient implant heavy. And what we'll be discussing today and what you saw on the start screen was our maxillary subperiosteal implant workflow. And we're also going to discuss our mandibular tooth carried bridge workflow as well. But as you can see here, we have several workflows available, reconstruction workflows, the orthodontic surgery, and maxillomandibular. And what's really great and what I want to discuss today is the workflows aren't just limited here in this anatomical region. We want to work with others and branch out to different sections of the body. So when we find partners and we can co-develop, we can put your workflow here. But again, we'll go into that a little bit more. So a lot of the questions that we get with the virtual implant testing, it's pretty basic, is how do I know what's the results on your software and the virtual implant testing reflect reality? So in order to do that, there's actually quite a lot of steps that we take. And one of them is physical testing. So for example, with our mandibular reconstruction workflow, we had 8 cadaver mandibles. 3 had the osteosynthesis plate on it, and then we had the other 5 were whole mandibles. And so those underwent physical testing. Those tests were measured, benchtop testing, and compared with the data, the assessment of the failure criteria. That data, for example, if this implant was titanium 2-3. Titanium 2-3 surgical steel, other titanium grades, and other materials have long been used in other industries such as the aviation industry and defense industry. So we know how those metals behave under certain loads and temperatures and things like that. So we have those hard default numbers and with software, and then also then we compare that to research that's already done. So CE marks and studies, we we compare it to up-to-date literature. So there's several different ways. And also what we do is we make sure that we, excuse me, so we make sure that we follow the FDA verification and validation groups. So the FDA has guidelines. There's no hard, how would you call it, regulations yet when it comes to simulation, but we follow those working groups. And just to piggyback on that, specifically the dental workflow that I'm going to show you, we have to take several things into account. And what we do at SimQ, since it's medical device related, we take all of those digital twin simulations, and we use sources like OpenSim, the benchtop testing that I referred to. And another example is with the dental workflow. You have different kinds of abutments, they're called, and some are metal and some are tooth supported. So the bridge or the crown can sit on top of a metal piece that's inserted by the dentist, or it can sit on a tooth that's maybe ground down a little bit, your natural tooth. And the difference is you can't just use the same calculation and say, okay, the bridge will behave this way if for metal or for tooth, because the tooth here has periodontal ligaments, and each tooth it moves a little bit as natural bone does because it's a living organ. So then we know that the force is dispersed differently and deforms differently when the implant is metal. But what's great is we've already done that foundational work. So we want to branch out and go ahead and start developing even further, more detailed workflows for dental. So that's the difference there. And that workflow is it's similar to what the workflow with the screen was for the subperiosteal implant. You can see here, there's a couple of different results, which we'll get into in a little bit. But again, you verify the mechanical strength and performance of medical devices and implants, and tooth or implant supported bridges. Like I said, we follow also MDR. We're also, a lot of times FDA is mentioned because they're putting out the guidelines, but we're also adhered to the MDR requirements as well. And then some administrative advantages. You can create documentation very easily because those are things that are mandated with personalized implants, and streamlines communication and integrate into already existing systems. So that's the goal there. Thank you so much for your attention. You have any questions for me so far? You can go, and if you have
Not so
any
far, Kelsey.
specific,
Thanks.
any specific questions, you can reach out to my CMO Florian as well. So,
Perfect. I think with
yeah,
that, we can hop over to VAT.
super. Okay. So where I want to start, this workflow example is a little bit one of the more complex ones. That being said, it still takes under 5 minutes to import everything. So what I did right now is I'm going right to the results screen. And then what we'll do in a little bit is go through a workflow with the dental model. So you can kind of see how we got here. But first, I want to just kind of go through the different results that you can see in this workflow. And then when you have some questions, also I know, Joseph, you have the engineering background. I'm more of on the medical side. So those two things and two worlds kind of come together with this software, which I think is really kind of cool because I'm more of the end user clinical applier. So here, a lot of engineers are probably familiar with material limit. And what I like about this is it's red bad, green good. So it's very hard to say, oh, I don't see where the problem is. So you can see here this design that no part of it, the material limit here, I believe it's a titanium 2.3, is exceeded. So this specific design As far as material limit is concerned, looks great. Then what we can go, the next one would be, again, is total deformation all. So all being the implant and the bone and the screws, all of the geometry here. So with the load, which I'll go ahead and show in the workflow steps, but we applied a load here, a load case here. And as you can see, when it's red here, it doesn't mean, it just means that the total deformation is above the 0.7 millimeter mark. It doesn't mean necessarily that something needs to be changed. It's just so you're aware that this is where it is. So the engineer has that knowledge. And you can see how the implant deforms. And it's staying in this level. So a 0.4 millimeter deformation is very good. You don't want the implant has to move a little, but it can't move over millimeters because it's just not, wouldn't be stable medically or structure wise. So you can see how it disperses, and over here there's not stress on the bones or any issues with the design. Here this will also, so the normalized strain of the bone, so you can see here the strain that's put on the bone around the screw holes. So when the person will chew a normal bite or what have you, you can see that the bone is also not taking in an excessive amount of force. Because medically, when a bone takes too much force or not enough force, you can have bone growth and you can have bone waning. So if the pressure is not enough on a bone, just like if you don't do weight training exercises, you can lose bone that way. So that's also another thing, is it's very important how these pressures are placed, not only with the implant design, but on the bone. Then here you get a little bit more in the engineering side of it. You guys know, I've learned what shear stress is and what tension stress is, and that's the type of stress that's on the implant when you're designing it. And you can kind of see that here. So that would be something I would encourage the design team to explain to the surgeons. And then what I like is the von Mises, or the equivalent stress, and that's all of the stresses combined. So you can see here that the implant is taking stress, but there's no red. These parts look good, and this would be a good quality design, because there you do intend some deformation where the load case is, but it's dispersed in a good way. If you wanted to, for example, maybe what I also, when we say improve the design, you could say, okay, what if I connected this piece here, for example, or what if I put another bar here? I connected and I put another bar here. Would that implant really, would it maybe make this a little bit more blue or what have you? So those are the things that VIT can help with. So that's what I think is really great. And we also have, what's important, the screw force. So again, when the implant is, for example, it's bitten down upon, that implant is going to put force on the screws, and the screws also on the implant. So we also take into account the screw, on each screw, the amount of force. So again, it might be red here, but it just indicates the Newton force on these screws is 27 or 28, almost 28. So then you would, this is more engineering, and then you could tell the physician, okay, this is what this normal force is, and you have the data that shows a normal bite, etc. So it's just showing you, okay, the highest force is on these screws here, which also makes sense because the load case was there. So those are the results very quickly for this, the most complex flow.
I like that also, Cassie. Yeah, also in terms of communication, right, that the engineer can actually look at the kind of quantitative results from an engineering point of view, or the designer,
Correct.
but then the physician or the doctor just looks at red bad, green good, which is like
Right,
the
and
much simpler way to
exactly.
understand.
And so with the material limit, that was easy. But sometimes, so when you see, that's not necessarily the case with the screw forces, just because the screw is under
Mhm.
a lot of load, it doesn't necessarily mean that the screw needs to be removed or needs to be changed in any way. It's just so you know, of all the screws, that one is taking the most force at 28 newtons, for example. The normal force the engineer would know would be this, and then you could say, okay, well, I don't like. Maybe let's try and lower the pressure or lower the Newton force a little bit and change that design. Like I said, maybe add a here and a bar, or if it's acceptable between the engineering and the surgeon and this bone quality is good, that's another thing. Then the surgeon will know, okay, yep, there's strong bone here. This was removed, but we have a good zygomatic arch here that can support that. And I feel confident that that's the right implant design for this patient. And then here's the
Really cool.
handy dandy PDF report that you can print. So you click that and it generates all of the facts that I shared with you. It generates that in a report. So it can go into your QM systems, and like with MDR regulations, you have to have certain documentation on things. So shows why you designed with what material in with this way.
That makes sense.
Right.
Great.
So
So I think with that, we can hop over to the dental workflow,
okay, great.
Kelsey.
So what's great, you'll go
Right?
back to the dashboard, and so this is what I was saying. So you do all of this for all of the workflows, but so I wanted to just do the mandible dental tooth supported bridge. So this is still a beta project workflow. So we have, like I said, we already have that foundation of the research and things, but we are looking to work with other companies, dental companies, to try to improve upon that. So this is a mandible reconstruction. We'll do. Okay, so see here we have the dental bridge. So we're just gonna click it. It takes STL files, so you just click on that and open. So very simple here. You can see this is mandible. And also the materials that I spoke about, we have a big library of materials, but also these are customizable. So that's also a great thing about the software. So for example, for 3D printing, a lot of people use 2.3 for what I've learned. And then we would just import the tooth stumps. So again, just as easy. There they are. Click next. Okay, and so it's going to be on the patient's right here. So it's 43, 44, 45, 46. So these are what's called landmarks, and they're in all of the workflows. So you set these landmarks based on the guide here, and this is going to put, it's going to assign the reference geometry model to this patient-specific bridge and stumps here. So the occlusal surface of 43, 44, 45, 46. Then what's important in this workflow, so you have a stump here, but you don't have a stump here, so you need to skip. And so we have a stump here, but we don't skip. And what's important is like that previous maxillary subperiosteal implant, you saw that there was a portion of the maxilla that is missing. So sometimes with these surgeries, you're not going to have a place to set landmarks, but it's nice because with these workflows, if you need to skip an area, um, it doesn't affect the quality of the simulation because sometimes they're just not there to register. So you would click register, and what this does is for this workflow, it registers to a known patient reference model. So you see the mandible here, and that the teeth are, so the patient-specific teeth here, and they have this reference model. So you can verify it's in good shape and overlapped well, so it's plausible, and we click verify. And then the types of load cases that are important for chewing and et cetera. Or so for example, if the patient has a bridge and they accidentally chew on a cherry pit, or they eat an olive and they don't realize that the olive pit is still inside. That could crack the bridge, or also everyday use. So you use that bridge to eat 3 meals a day, and so chewing cycles. So what I like to do, we'll just do the chewing, and you have this main force here, so, which you can move. You just highlight the sphere as well. So I like to kind of put it over maybe more of the delicate tooth. If you're to chew, have a pit on one with an abutment, okay, maybe it's either metal or tooth supported, so it could take it, but you maybe want to see the one in the middle, how it would. And in this workflow, these are where the supports are. So this is the anchoring, and this is how the simulation is applied. So the force down here, and then this is the base, because you have to apply force on a fixed space. Otherwise, it can't, physics. So you just click next. And then you send the simulation to the server. So with these models, I think we're down to about 5 to 10 minutes because they're smaller and quick. And then with the mandible one that I showed, or maxillary one that I showed, is a little bit more complex. So that can take about 40 minutes or so. But these times are getting faster and faster with each update and computing power. So that's something that's just going to continue to improve there. I think that's it. So we can just go back to the dashboard. I can show very quickly the dental bridge here, the results. And again, similar to the results that we went through with the maxillary. So you can see that force is there. However, it's deformed, but it's not deformed in these crevices here. So it's taking the force where it should. So it's a good design there. So that's it from my end for the VIT.
Great. Did you want to show anything else, Kelsey, or was that it?
That was it. So we'll just say
perfect.
stop
Let's
sharing.
check the questions. I think it's a more specific one, more technical one from Ismail. Thanks for the presentation. Are you considering bone remodeling / osseo integration in your numerical models? This is probably
So,
one for the engineers, I guess.
well, actually, yes. So the actual integration into the software, but I know from the medical perspective, the osteo integration. So again, we had already touched about this, I think, before we started recording. Bone density and bone quality and individualized bone characteristics are always asked of us. So the thing is when you're doing a mandibular reconstruction, is the bone the same of a 21-year-old athlete male who maybe had an injury and it's a revision or something? Yeah. And then what about the 82-year-old osteopenic or osteoporotic woman who has a cancerous mass removed from her jaw? Two totally different scenarios. So the bone density that is accounted for in VIT is a normal, healthy bone. It's not possible at this point in time to do individualized bone density or osseointegration. That is where the surgeon comes in, and the surgeon can say, okay, it's appropriate to do osseointegration, osteosynthesis, or they can say this bone is not healthy enough to put a screw in. So the VIT is implant design and doesn't account for bone density, but I'm hoping as digital twin technology improves, we can all have a patient-specific or an individualized medical twin. Wouldn't that be nice?
Definitely. Really cool. Thanks, Kelsey. We had one question on YouTube regarding the digital twin and SimQ's work. So I actually posted the website of SimQ, which you can also find in the LinkedIn chat. So you can check out what you're actually working on in terms of digital twins.
Yep.
Cool. There's no more questions. We'll give it 1 or 2 more minutes. Kelsey, anything else?
Okay.
Any closing remarks from your side? How can people reach out?
Yes, please. So visit our website. You can email me, kcrossman@simq.de. Yeah, we not only do we offer the virtual implant testing, but SimQ is a medical simulation company. So we use simulation in a lot of different ways. You could do computational fluid dynamics for individualized airway mapping. We do a lot of consulting services. So if you're trying to find a prototype or a place to start your clinical study, maybe you have a couple of prototypes, but as you know, it's expensive. So if you need some types of testing that way, we offer virtual benchtop testing. Um, if you're interested in co-development of other anatomical regions, dental specifically, we're coming along with that. So that's should be up and running out of a beta version soon. Of course, I'm interested in hip, knee, shoulder, things like that. But also, yeah, we do a lot with simulation. Also, uh, virtual patient cohorts. So maybe like the digital twin. So trying to eliminate or to improve time, money, and resources when it comes to clinical studies testing. And so I'm hoping with simulation it's going to be kind of in the regulatory. Have you done animal testing, virtual patient cohort testing, and maybe your first in men study? So it's going to be all three of those things, and hopefully
Mhm.
reducing
Perfect.
animal and human testing in the future. That would be the goal.
Yeah, great. I mean, apart from the dental workflow, which is, I think, also a first step to showing what SimQ can do, we can also maybe do another workflow, maybe CFD, machine learning support, all that kind of stuff that you also offer at SimQ in one of the subsequent deep dive series. But as there are no more questions, Kelsey, thank you so much, by the way, for taking the time.
Yeah, thank you.
And hopefully we'll see you in a second or third part in the future.
Yes, I would love that. Thank you. And
Have a
again,
nice
reach
day.
out if you have any questions or input. We appreciate it.
Thank you so much.
Bye-bye.